All right, today we're talking about adding and subtracting polynomials. Today we're just going to write polynomials in standard form. Tomorrow we're going to add or subtract polynomials. So a polynomial is a monomial or the sum of monomials, each called a term of the polynomial. Some polynomials have special names. A binomial is the sum of two monomials, and a trinomial is the sum of three monomials. So for example, we've already talked about monomials. This would be a monomial. It's one term, okay? Binomial, this is an example. This would be two monomials added together. This is an example of a trinomial. This would be three terms that are added or subtracted together, okay? All right. So then we take a look. Once you identify whether it's a monomial or polynomial, then you're going to figure out what degree it is. So the degree of a monomial is the sum of the exponents of all of its variables. A non-zero constant term has a degree of 0, and 0 has no degree. So for example, if we just had a constant of 6 with no variable, that would be a degree of 0, okay? Now, the degree of a polynomial is the greatest degree of any term in the polynomial. So you can find the degree of a polynomial by finding the degree of each term. Polynomials are named based on their degree. So a linear is first degree, quadratic, second degree, cubic, third degree, so forth, okay? All right. So in this, it says determine whether each expression is a polynomial. If it is a polynomial, find the degree and determine whether it is a monomial, binomial, or trinomial. So in this first expression, we have 4y minus 5xz. Is it a polynomial? Yes, it is a polynomial because all you're doing is adding two monomials together, 4y and negative 5xz. So that makes it a binomial, okay? So it's a binomial, it's two terms. Now it's the second degree. Now how it's the second degree is because of these two monomials that we're adding together, 5xz would be 1, 1. We add those together, so the sum would be 2. So that means the degree would be 2, okay? Now b, negative 6.5, yes, it is a polynomial. It's a monomial, but it's to the degree of 0. There's no variable on there, okay? So constants are degree of 0. Then on C, we have 7a to the negative third plus 9b. This is not a polynomial. And the reason being is, remember, this negative exponent up here means that you would write it like this. 7 over a to the third power, which is not a monomial because there could be a 0 down there. And if there's a 0 in the denominator, it's undefined. So it's not a monomial, okay? D, 6x cubed plus 4x plus x plus 3. This is a polynomial. And since we have, we can take a look at what is the largest exponent. The largest exponent is 3. So therefore, it is a degree of 3, and it is called a trinomial, okay? A trinomial. Remember, it's named based on the degree. All right, so determine whether each expression is a polynomial. If it is a polynomial, find the degree and determine whether it is a monomial, binomial, or trinomial. All right, so let's take a look. Number 1, 36. Is that a polynomial? Yes, it is. What degree is it? It's a constant, so it'd be a degree of 0. And then is it a monomial, binomial, or trinomial? This would be a monomial. Okay? Number 2, 3 over q squared plus 5. Is that a polynomial? No, because of this right here. Okay? All right, number 3, 7x minus x plus 5. Is that a polynomial? Yes, it is a polynomial. What degree is it? it would be a degree of 1. And then is it a monomial, binomial, trinomial? This would be, since it's a degree of 1, it is a binomial. Okay? All right. Number 4, is this a polynomial? Yes, it is a polynomial. And we take the monomial, and we have 2 of them here, and we take the degree of the largest. Well, in this one, we have an exponent of 2 plus an exponent of 1 for the h. In this one, we only have 1, 1, so that would be 1 plus 1. This gives us a 3, this gives us a 2, so our largest is 3, so that would be a degree of 3. And this would be a trinomial. Okay, so remember, you take your monomial, and which has the largest exponents, largest sum of exponents, would be your degree. In this case, it would be a 2 plus 1 would be 3. Okay? All right. So the term of a polynomial can be written in any order. However, polynomials in one variable are usually written in standard form. The standard form of a polynomial has the terms in order from greatest to least degree. In this form, the coefficient of the first term is called the leading coefficient. Okay? So once you get it here in standard form means your greatest degree. So in this case, the exponent of 3, then it goes 2, then it would go 1, then it would go no variable. Okay? A constant. The coefficient here at the very beginning, that is our leading coefficient. Okay? All right. So we are to write each polynomial in standard form and identify the leading coefficient. So if we have this here, we have a 1, a 5, and a 2. Okay? So the first thing that we're going to do is 5 is the greatest. So we're going to rewrite that as 4x to the 5th. Okay? Now whatever sign is in front of it goes with it. Okay? Then we have 3x squared is the next largest, so plus 3x squared. Then look here, minus 7x. So that negative sign goes with it, so minus 7x, which is what they have right here. And our leading coefficient is the coefficient at the very beginning, so the leading coefficient is 4. Okay? Let's take a look at another one. We have 5y minus 9 minus 2y to the 4th minus 6y to the 3rd. Well, let's take a look at what we have. We have 1 as a exponent. We would say 9 is 0, just because it doesn't have a variable. It's a 0 degree, should I say. And then it has 4 and 3. Okay? So we take a look at that. Well, the 4 is the greatest. So we're going to start off with, again, remember we're going to use the sign in front of it goes with it. So negative 2y to the 4th. Then we have a 3 as the next. And again, it's minus 6y. So minus 6y cubed. Then we have the 5y, and there's no sign in front of it, so it'd be plus 5y. And then we follow it up with our constant of negative 9. Okay? And then what is our leading coefficient? It would be negative 2. All right. So let's look at these. We are to write the polynomial in standard form and identify the leading coefficient. So if we take a look at here, we have a 3, we have a 5, and we have a 2. And they're all the same variable. So I would say x to the 5th plus x to the 3rd minus x squared. Now, what's my leading coefficient? I don't have a number in front of the x to the 5th. But remember, there's always that invisible 1. So my leading coefficient would be 1. Okay? All right, let's take a look at here. We have a 4, we have a 3, we have a 5, and a degree of 0. So we'll do the 5th degree first. we have to take that sign with it. So negative 7x to the 5th plus x to the 4th plus 4x to the 3rd plus 1. Okay? Now what's our leading coefficient? And it's going to be negative 7. Okay? All right. Last one. So let's change the color just because we're getting a little close. So this would be a 6, this would be a 5, and this would be a degree of 8. So we would take the 8th degree, so 2x to the 8th, then the 6th degree, negative 3x to the 6th, and to the 5th degree, negative x to the 5th. And what is my leading coefficient? 2. Okay? All right, if you got any questions, let me know. Otherwise, have a great day.